Hi, welcome to this Corbettmaths video. In this video we're going to look at how to solve trigonometric equations. So we're going to be looking at solving trigonometric equations part 2. In our last video we looked at how to solve trig equations whenever the values of x or theta that we were looking for were between 0 and 360 degrees. In this video we're going to look at other intervals, so rather than between 0 and 360 we may be looking at between negative 180 degrees and 180 degrees. We might look at other intervals such as negative 90 degrees to 270 degrees. We may even look at intervals such as negative 360 degrees to 0 degrees. But in this video we're going to look at other intervals other than from 0 to 360. We're going to look at these other intervals. Now before we do that, I think it's important that we go back to the cast diagram and we look at the cast diagram again and consider in terms of the positive angles but also the negative angles and how they're represented on the cast diagram. So here's our cast diagram. We've got 0 degrees here on the positive x-axis, and we looked at in our previous videos in the introduction to the cast diagram the positive angles were measured anti-clockwise from this line. So if you go around anti-clockwise, that's the positive direction. So if you were to start here, if you go around to 90 degrees, you'd be here, so that's 90 degrees there in purple. If you go around another 90 degrees, that'll be 180 degrees there. If you go around another 90 degrees, you get to 270 degrees, which is there. And if you go around another 90 degrees, that'll be 300 degrees, and that would be there. So that'll be a full circle. So that's how you represent positive angles on the cast diagram. So if we wanted to show 300 degrees on the cast diagram, we would start here at 0 and we'd go around 130 degrees anti-clockwise. So 90 degrees would be there, so then we'd go another 40 degrees. So it would look something like this. So we'd get our ruler and pencil, we'd draw a line, we'd measure another 40 degrees after the 90, and then that angle there would be 130 degrees. And that's it. If we wanted to show a negative angle on the cast diagram, we go around clockwise. So here, if we want to show negative 60 degrees on the cast diagram, that's what you get when you start at the positive x-axis and you go around clockwise. So negative 90 would be down there. Negative 180 degrees would be there, negative 270 degrees would be there, and negative 360 degrees. So if we want to show negative 60 degrees on the cast diagram, we get our ruler and our pencil. We would measure 60 degrees clockwise, so we would measure 60 degrees going down this way, and we'd draw a line. And then that angle would represent negative 60 degrees. It'd be negative 60 degrees. It's going around clockwise from that 0 line. And that's it. So positive angles will be going around anti-clockwise, and negative angles will be going around clockwise. So let's have a look at a question now and see how this would be used in a question. So here we've got another trig equation. It says solve sine x equals 0.2 for values of x that are bigger than or equal to negative 180 degrees but less than or equal to 180 degrees. So we're going to approach this question in the same way as we did in solving trig equations part 1. So what we would do is we would do the inverse sine of 0.2. So we do the inverse sine of 0.2, and when we do on our calculator shift sine of 0.2, that gives us an angle of 11.537 to 3 decimal places. So that's the inverse sine of 0.2, and now we're going to represent this on the cast diagram. So remember, we get our ruler and pencils and we're going to draw on those acute angles. So they would go there, 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 and there. And we would mark in 11.537 degrees in each of them. So here 11.537 degrees, here 11.537 degrees, here 11.537 degrees, and here 11.537 degrees. So we've marked on our angles on the cast diagram. So now what we want to do is we want to find our angles, so our solutions to this equation. So to do that, what we're going to do is we're going to first of all consider which quadrants we're looking at here. So here the 0.2 was positive, so we want the quadrants where the sign is positive. And the sign is positive here in this quadrant, so the quadrant is labelled A, the first quadrant, and it's also positive in the second quadrant there as well. So that means that the sign will be positive here and here. So we're going to be looking at this angle and this angle here. We're not really focused on these two here. Okay, so we're going to focus on these two quadrants here. Now we're going to start at 0 here, and because we want to find the values of x between negative 180 degrees and 180 degrees, we're going to consider this in two parts. We're going to consider the angles between 0 and negative 180 degrees, and we're also going to then consider the angles that are positive, so the ones between 0 and 180 degrees. So let's start off with the angles that are negative. So that means you start here at 0, and we're going to go around to negative 180 degrees. So that means you're going to go around 1, 2 quadrants. So either this quadrant or this quadrant if you're going around clockwise, and you get round to negative negative 180 degrees. Now actually no solution in either of those quadrants would work because we're looking at these two quadrants up here. Okay, now in terms of the positive solutions, so we're going to start here at 0 degrees and we're going to go around now anti-clockwise to 180 degrees, and we're going to see if there's any solutions in those quadrants. And as you can see, yes, we've got our first solution and we've gone around 11.537 degrees. So that's our first solution, 11.537 degrees. That's our first solution. And then if we go around, then we've got our next solution here. And to find this solution, what I would do is I would take 11.537 away from 180 degrees, and that would give us the size of this angle here. So 180 subtract 11.537 is equal to 168.463 degrees. And that's it. So if we were asked to solve the equation sine x equals 0.2 for values of x that are bigger than or equal to 180 degrees but less than or equal to 180 degrees, the two solutions would be x is equal to 11.537 degrees or x is equal to 168.463 degrees. And we found that by just considering from 0 around to negative 180 degrees, and there were no solutions there. And we also consider from 0 around to 180 degrees, and there were two solutions there. So there are two solutions. Okay, let's have a look at our next question. So our next question, there will be some solutions which have negative angles as solutions. So let's have a look at those. Okay, so our next question says solve cos x equals negative 0.5 for values of x that are bigger than or equal to negative 180 degrees but less than or equal to 180 degrees. Okay, so let's solve this equation. So the first thing we would do is we would do the inverse cos of 0.5. So thinking back to that solving trigonometric equations part 1 video, we would do the shift sign of just this value here. We ignore the negative and we just do the inverse cos of 0.5. So we're going to do the shift cos of 0.5 and we get that's equal to 60 degrees. You may know that off by heart, but remember you can work it out in the calculator if you want to. So the inverse cos of 0.5 is 60 degrees. So that means we're now going to go to our cast diagram and we're going to label those angles. So we're going to label the 60-degree angles between the lines and the x-axis. So that means we've got our 60-degree angle here, our 60-degree angle here, our 60-degree angle here, and our 60-degree angle here. And let's label our quadrants C, A, S, and T. Okay, so we've now got a cast diagram. Now let's consider which quadrants we're looking for. So here we've got negative 0.5. So we want to find the quadrants where the cos is negative. So the cos, so the cosine, will be negative in this quadrant here and this quadrant here, because the cos is positive in this quadrant and this quadrant. So that means in these two quadrants here, the cosine will be negative. Okay, so we're nearly there. Now we just need to find the angles. So because the interval is between negative 180 degrees and 180 degrees, we're going to consider this in two parts. We're going to consider them from 0 around to negative 180 degrees, going around clockwise. And we're also going to consider from 0 going around to 180 degrees anti-clockwise. Okay, so let's consider the negative angles. So we're going to start here at 0 degrees and we're going to go round to negative 180 degrees. So here we've got negative 90 degrees. And if we're going round, we've got this solution here. So we want to find the size of this angle here. Now that angle would be 120 degrees because if that's 60, that's 120. But remember we're going around from 0 round in the clockwise direction, so that's going to be a negative angle. So our first solution would be negative 120 degrees. So we've got negative 120 degrees, we get round to negative 180 and then we stop here at negative 180. So there are all our negative solutions going around from 0 to negative 180 degrees. So there's that one solution there which would be negative 120 degrees. And you can check it out in the calculator. If you do the cos of negative 120 degrees on your calculator, you get that's equal to negative 0.5. So that's one solution. Now let's go around and get the positive solutions. So we've gone from 0 around to negative 180 degrees. Now we need to go from 0 around to 180 degrees. So we're going to go around now in the positive direction. So if we start here at 0, we're going to go round. So we get to 90 and then we get to here. And this is a solution that we want. So we want to find the size of this angle here. And if that's 60, that means that would be 120 degrees. So that's our other solution, 120 degrees. So there are two solutions, that either x is equal to negative 120 degrees or x is equal to 120 degrees. And that makes sense. Now, if you think back to the cos graph, remember it's symmetrical. You've got that line of symmetry going through the y-axis. So if one solution is going to be 120 degrees, the other one will be negative 120 degrees. Does that make sense there? Okay, let's have a look at another question. Okay, so this time we've got another question. It says solve tan theta equals 1.5 for theta is bigger than or equal to negative 180 degrees, but less than or equal to 180 degrees. Okay, so let's do our cast diagram here. So we've got our cast diagram there, and actually before we do that, we need to find the size of the angles, the acute angles that we want to draw on the diagram. So we're going to do the inverse tan of 1.5. And when we do the inverse tan, shift tan of 1.5, we get that's equal to 56.31 degrees. So that means we're going to put that angle on our diagram. So we're going to do those acute angles. 56.31 degrees. This angle here would be 56.31 degrees. This angle 56.31 degrees, and this angle 56.31 degrees. Now let's label our quadrants C, A, S, and T. Okay, now we need to figure out which quadrants we're interested in. Here 1.5 is positive, so that means we're looking for the quadrants where tan is positive. So that would be this quadrant here and this quadrant here. The tan is positive in both of those quadrants. So they're going to be the answers that we're going to be looking for. Okay, so now let's have a look at our interval. We're looking for theta. Is it bigger than or equal to negative 180 degrees, but less than or equal to 180 degrees? So that means we're going to go from 0 around in the clockwise direction, around to negative 180 degrees, and get any solutions. So remember, they're negative angles. And then also we're going to start at 0 degrees, and we're going to go around anti-clockwise to 180 degrees and get any positive solutions. So let's start off with the negative solution. So we're going to start here, and we're going to go around clockwise. So there's none in that quadrant, and then we're going to go around to here, and that will be our first solution, this one here. So if this is 56.31 degrees, if we take that away from 180, we do 180 subtract 56.31, we get that's equal to 123.69 degrees if we go around that way. Also remember, we are going around in the negative direction there, so we're going around from 0 around to here, and that's a negative solution. So that means that theta would be negative 123.69 degrees. That's our first solution, just going around from here around to there, and we're measuring the sides of that angle, but because we're going around the negative direction, it's a negative angle, so negative 123.69 degrees. And then if we go on around to negative 180 degrees, that's the only solution there. In those two quadrants, the only solution would be that one. Okay, now let's go around the positive direction, and we're going from 0 around to 180 degrees, so we're going to go from 0 around to 180 degrees. So there's only one solution there, and that's this first one of 56.31 degrees. So 56.31 degrees. And that's it. They will be our two solutions for this question. So that means that theta is equal to either negative 123.69 degrees or 56.31 degrees. And that's it. Okay, let's look at our next question. Okay, let's have a look at our next question. So our next question, we've been asked to solve sin x equals negative 0.7 for values of x that are bigger than or equal to negative 90 degrees, but less than or equal to 270 degrees. Okay, so with this question, the first step, let's do the inverse sine of 0.7 and see what that's equal to. So shift sine 0.7 is equal to 44.43 degrees to two decimal places. Okay, now let's draw that on the cast diagram. So let's get our cast diagram drawn. So here we've got our two lines, and then we've got our angles. And then we're going to mark on our 44.43 degrees, 44.43 degrees, 44.43 degrees, and 44.43 degrees. And let's label them C, A, S, and T. Okay, so we've got our cast diagram drawn. Now let's figure out which quadrants we're interested in. Now here we've got the sign is negative. We've got negative 0.7. So which quadrants is the sign negative in? Well, that would be the C and the T. These two quadrants, the sign is negative in. Only the cosine is positive here, and only the tangent is positive here. So that means we're interested in this one and this one here. Okay, so now let's find our solution. So x would be equal to, now we're going from 0 around to negative 90 degrees, and then we're going to be going from 0 up to 270 degrees. So let's start off from 0 down to negative 90 degrees. So we're going to start here at 0, and we're going to go around to negative 90, which is here. And there is a solution there. There's this solution here, which would be, now remember we're going around clockwise, so it's going to be negative 44.43 degrees. So that's our first solution, negative 44.43 degrees. Now when we get to here, we've got to negative 90 degrees, so we're not going to go any further because we're only going down to negative 90 degrees. We're not going to go any further there. So that's our first solution there, and we're going to stop. Now if we go back to 0, we now need to go round to 270 degrees. So that'll be 1, 2, 3 quadrants. So 90, no solution there. We're not interested in that one. No solution there. And then if we go around to 270 degrees, we have got this solution here. So this solution was be another solution. We're going around from 0 all the way around to here. So to find the size of that angle, that's 180 degrees when we get to there. And then another 44.43 degrees. So 180 plus 44.43 is equal to 224.43 degrees. And that's it. And we stop there because that's 270. And that's it. So there are two solutions, that x is negative 44.43 degrees, and we've also got 224.43 degrees. And that's it. Okay, let's have a look at our next question. So our next question, we've been asked to solve 5 cos x equals 3 for values of x that are bigger than or equal to negative 180 degrees, but less than or equal to 180 degrees. Okay, now in terms of this question, I'm going to divide both sides of the equation by 5 to begin with. So we'd get that cos x equals 3/5. Just dividing both sides of that equation by 5. You could write cos x equals 0.6 if you wanted to, but we just want that cos x there. Okay, now we're going to do the inverse cos of 3/5. And when we do the inverse cos of 3/5, we get that's equal to 53.13 degrees. Okay, that's fantastic. Now let's draw a cast diagram. So we've got our two lines, we've got our angles, and we're going to mark in our acute angles of 53.13, 53.13, 53.13 and 53.13 CAST. Now here the cos is positive, so we're looking for the quadrants where the cosine is positive, so that'll be quadrant 1 and quadrant 4 there. Okay, so the cosine is positive in those quadrants. Okay, now let's have a look at the values of x. We're going from negative 180 to 180. So we're going to go around from 0 around to negative 180 to begin with, and then we're going to go from 0 up to 180 after that. So if we start at 0 here, actually x, we have got, if we go around in the negative direction, so negative 90 degrees, well, we've got a solution there to begin with. We have got negative 53.13, so negative 53.13 degrees, because we've gone 53.13 degrees in the negative direction. And then if we go on around, we get to negative 90, and then around to negative 180. So that's our only solution between 0 and negative 180 degrees. Now, if we go around from 0 up to 180, well, our first solution there, if we go around from 0 to 180, we're going to get 53.13 degrees, and then we're not interested in that one, so that's it. So there are two solutions, that x is negative 53.13 degrees and 53.13 degrees, and that's it. Okay, let's have a look at our last question. Our last question, we've been asked to solve cos x equals negative 2/3 for values of x that are bigger than or equal to negative 360 degrees, but less than or equal to 0 degrees. Okay, so let's do the inverse cos of 2/3 to begin with. So 2/3. Remember, you just ignore the fact it's a negative. That'll just let you know what quadrant you're interested in. So if we do the inverse cos of 2/3, we get that's equal to 48.19 degrees. Now let's draw that on our cast diagram. So let's get our ruler and pencil and draw our cast diagram. And then we're going to put in there our 48.19, 48.19, 48.19 and 48.19 degrees. And that's C, A, S and T. Okay, now here, if we go back to the question, we had cos x was negative 2/3, so negative, we're looking for the quadrants where the cos is negative, so the cosine will be negative. Well, it's going to be positive here, it's going to be negative in this quadrant and negative in this quadrant, so these are the two quadrants we're interested in. Okay, so now let's find the values of x. So here we're going to be going from 0 around to negative 360 degrees, because we're looking at values of x between negative 360 degrees and 0 degrees. So we're going to start at 0 degrees and we're going to go round to negative 90, negative 180, negative 270 and negative 360. So we're going to go around just clockwise here. Okay, so let's have a look. Between 0 and negative 90 degrees, no solutions. We're not interested in that one. Then if we go around to negative 180, well, there's another solution here. So we want to find the size of this angle here, going around in the negative direction. So if we do 180, take away 48.19, so 180 minus 48.19, that means that this angle here, going around from here around to here, would be 131.81 degrees. Now remember, we're going around in the negative direction here, we're going around clockwise, so that means our first solution would be negative 131.81 degrees, because we're going around negative 131.81 degrees. Okay, so we've got to negative 131.81 degrees. We're going around to get to negative 180 degrees. Then if we go around, we've got another solution here. So we're going to add 48.19 degrees onto 180. So 180 plus 48.19 is equal to 228.19. So that means our next solution will be negative 228.19 0.19 degrees, because we've started here at 0 and we're going round in the negative direction, and we've gone round to negative 228.19 degrees. And then if we go on round, we get to negative 270 and negative 360, and we're done. So there are solutions that x is equal to negative 139.81 degrees and negative 228.19 degrees. And that's it. And that's it. So in this video, we've looked at how to use the CAST diagram to solve more trig equations. But this time, rather than looking at just between 0 and 360 degrees, we've looked at other intervals for x and theta, so including some negative angles, so such as from negative 180 to 180, or even from negative 360 to 0, and so on. So I really hope you found this video useful. In our next video, we're going to look at some more complicated trig equations, and we'll have a look at this. So I hope you found this video useful, and if you have found it useful, please like and please subscribe to my YouTube channel. Thank you. Cheers. Bye.